Using the APS and displacement tools found in LightWave 9, we're able to displace millions of polygons in a short amount of time to create objects with the tiniest of details. This can be used for landscapes such as this example here, where we're rendering 1.7 million polygons in roughly 30 seconds. You can also use the APS and displacement tools to generate fur. Let's take a look at a few examples. In these examples, I've displaced millions of polygons to generate fur across the geometry, whether it be for dog hair, as in these examples, or a child's hair where I'm actually combing the fur or the hair in the direction that I want it to go, or say something like AstroTurf, and of course fur again on Totoro. Let's take a look at how this is done. It's actually an easy process, and I'll walk you through it. In this example, we'll take this sphere and displace the geometry so that we get fur across the surface. Now, for starters, let's take a look at the object properties, and we'll come over here, and we can see that our display subpatch level is set to 3, and our render subpatch level is set to 3. Well, I'm going to crank this up because I want to render lots of geometry so that I have more geometry to displace at render time. So I'm going to go ahead and let's go ahead and set this to say 40, and let's go ahead and render and see how many polygons that's going to give us. Let's hit F9, and we start off with 2,800 and we end up with 500,000 at render time. That should be enough. That's 500,000 polygons, and that should be enough to work with. I'm going to go ahead and close this down. We're now ready to displace the geometry. So I'm going to go back to Object Properties, come over to the Deform tab, and let's use the Edit Node. So I'm going to go ahead and check this because I want to go ahead and use the node displacement that we're going to set up, and we'll open up the node editor. And by default we have our displacement node, and let's go ahead and set up the nodes that we need. I can pick any procedural, but I'm going to go ahead and pick noise, and I want it to be at such a small scale that it shoots out small little fibers. So I'm going to come over to scale here, and I'm going to set it to something really small, like 2 millimeters. And then I need to feed this into my displacement, but I need to tell it what direction do I want to displace. So I'm going to add a spot node, okay, and I'm going to add a scale vector node. So I'm going to feed the normal into the vector, so it's based off the surface normal of the object. I'm going to feed the noise into scale and drop that into the displacement node. Okay, so let's go ahead and close this down, and we can see that our object is being displaced already. Since our display subpatch level is set to 3, we're only going to see so much displacement here. So let's go ahead and do a render and see what it looks like when we're subdividing it at a subpatch level of 40. So as you can see, in 5 seconds we've got 500,000 polys and we've got our little fur fibers. They're a little crisp, but there's a way that we can go and soften those up. So let's take a look. We need to go back to our node editor, so I'm going to go to Properties, Deform, Edit Nodes, and under our procedural texture, I'm going to come over here to Rotation, and I'm going to set an envelope. And what I'm going to do is I'm just going to animate it over 1 frame, and I'm going to set that to repeat. And I'm going to go ahead and do that for all channels so that our fibers are moving a little bit over each frame, but it'll move the same over all frames. So I go ahead and close that down. And then we need to hop over to our camera properties, and we need to go ahead and turn on anti-aliasing. I'm going to go ahead and set it to enhance low, and very important, we need to turn on motion blur. That's going to help soften up the fur as it's being moved. So I'm going to go ahead and close that, and we'll do a render, and we'll pop that up. And in 17 seconds we've got the same 500,000 polys, but now they're softer, so it looks a whole lot more like fur. On the dog, for example, I wanted to displace the geometry to create fur where the fur needed to be, but I didn't want it to affect, say, the nose or the teeth or the tongue or the eyes. I can control where the displacement will take place, and in this case, I'm using a weight map. So let's take a look at that. I've created a simple weight map on the same sphere that we've been displacing, and I have 100% on the top and bottom, and I have 0% on the middle. It's actually really important that you have some kind of value on the points, even though they're 0%. If I click this point here and hit I for info window, we'll see that there is a value, even though it's 0, there is a value for that point. If there's no value, this won't work because it needs to know that what value each point on the object has, and in this case I've got 0 running through the center. So let's take a look at what that's going to look like when we render it. Let's apply the weight map to the displacement. I'm going to go back to Properties, Edit Nodes, and I'm going to go to the Add Node, Vertex Map, Weight Map. Okay, and I'm going to slide over here, pick the weight map we created, and then I'm going to attach it to opacity. Okay, we can close this down. We can already see what's taking place. Even though it's not the soft fur, we can see that the center area that we have a value of 0, there's no displacement taking place. And of course on top and bottom there's displacement. Let's do a render and see what that takes a look like. And in 17 seconds we've got our 500,000 polygons, except only the top portion is displaced and the middle of course isn't and the bottom is. So we can control where the displacement takes place with using a simple weight map. To generate the hair on this kid, I used a technique that I picked up from James Wilmot, where instead of using a weight map to control where the displacement will take place, we're using a morph, and we use a morph map in order to apply it. The morph map controls not only where the displacement will take place, but the length and direction the displacement will take place. Let's take a look at how simple this is to set up. To use this technique, we need to create a morph. So I went ahead and created a morph where I want the displacement to take place, or where I want the hair. I move the points, and I move them. In this case, I rotated these forward, I pulled these down a bit, and I only moved the areas that I want hair. Now, even though I only want hair here, I still need to have a value for the morph, kind of like what we were doing with the weight map. So if I hit I, we'll see that the same morph is applied to this point, but nothing is moving. And that's very important, because if you don't have a value on any of these points, it will displace the geometry. So let's hop over to Layout and see how this works. I've got the character loaded up in Layout. Let's go over to Object Properties. And first we'll see that we've got a subpatch level of 30. Again, I can crank that up even higher if I want, but I'm going to go ahead and leave it at 30. Go to my Deform tab, Edit Nodes. I've already got a displacement node here, the procedural texture crust, and if we go to Scale, we'll see that I got the 2 millimeters as before. Last time we used the noise. I'm just showing that you can use just about any procedural texture you want. Once you get it small enough, it all kind of becomes the same, but you can get slightly different effects. If we come over to position, I went ahead and set the envelope up on position instead of rotation, just to show again, as long as the fibers are moving, you'll get the same softness. Okay, so I'm going to go ahead and add our morph map. So I'm going to go to Add Node, Vertex, Morph Map, and I'm going to select the morph that we were looking at over in Modeler. I'm going to feed the alpha into the amount, and the position, feed it over to the displacement, and as we can see, you can already see in OpenGL where the hair is going to be, and you can actually see the direction. You can see that the hair up top is kind of rotated forward. It starts to fade off because of the amount of movement of the points, and then here I've got the direction going towards the ear. Let's do a test render and see what the result is. And in 45, just say 46 seconds, we've displaced 1.3 million polygons to generate this hair. Let me go ahead and close this down. And so you can see the full head of hair. And I'm also using, in the surface nodes, I'm using the same morph map and a gradient to say the distance that it's being displaced. I want to go from a dark color to a lighter color. So you have so much control with this setup, and with one simple morph, we've not only determined where we want the displacement to take place, but the length of the displacement and the direction. So you can do combing with this technique. I'm sure some of you are asking yourselves, well, can this be animated? Well, since we're repeating the same motion in the graph editor, we can go from frame to frame and we won't see any jittering because it's the same motion being repeated, and then the motion blur is softening up that movement. So we can have animation on this from frame to frame. We can also use dynamics on our displaced geometry with the simple use of metal ink. What I have in this scene is two objects. The blue sphere is going to be my dynamic object, and the one that's selected, the yellow one, is my displaced geometry. That is the sphere that we used earlier when we displaced it to create a fur ball. Okay, so in this scene, if I select my dynamic object and go to properties, you'll see that I've applied cloth effects. I've got a fixed point set that's the top of my sphere. I'm using -9.8 gravity with the preset of cotton thin, so I'm using very basic settings here, and I'm going to go ahead and close that. And if we scrub through, you'll see that the top stays put because I fixed that, and the rest of the geometry gets pulled down by the gravity. Now, that's what I want to happen to my fur ball. So what I'm going to do is take advantage of Metal Ink, which is a very powerful dynamic tool. And the first thing to know about Metal Ink is that in your scene editor or in your motion options, you need to parent the higher poly object, which in this case can be millions of polygons if you want, to the object that you've used dynamics on. Okay, and then what we're going to do is go to the properties panel, go to our displaced geometry, and you can see that we're using the same setup that we had before with the noise and the spot node and the scale vector node, feeding it into the displacement. But what I need to do is I need to change the node displacement order from before local displacement to after morphing. I'm going to go to Add Displacement, and I'm going to use Effects Metal Ink, and then I'm going to use Effects Metal Ink Morph, okay? Because that's going to allow me to displace my geometry before Metal Ink tries to use dynamics on the object, okay? And if we scrub through, we'll see that our dynamic object is controlling our displacement object. Here's a quick render. It's 30 frames showing the fur being displaced, the geometry being displaced with dynamics using cloth effects and Metal Ink along with Metal Ink Morph. This technique allows us to displace millions of polygons but still take advantage of the dynamic systems in LightWave 9. These are just a few examples of what you can do when you combine the power of APS and displacements in LightWave 9.